Julian here from Tutoring, and as always, it's such a pleasure to join you. Today we're going to be looking at question number 6 from the DBE Math Paper 2 2019, and this question is a trigonometry question. Okay, so question 6.1, determine the general solution of cos x minus 30 equals 2 sine x. So to start off, for this one we need to use the trigonometry formula, which is in your formula sheet, that states that so cos of a minus b equals the cos of a times the cos of b plus the sine of a times the sine of b. So that's straight out of your formula sheet. So therefore we're just going to simplify this left hand side. So this will become cos x times the cos of 30. Already we can start thinking about special angles, plus the sine of x times the sine of 30. And of course this still equals 2 sine of x. And as I said, now we have two special angles, which is your cos 30 and your sine 30. So special angles you should know off by heart, but in this case it does say you're allowed to use a calculator. So we know then that cos of 30 equals root 3 over 2. We also know that the sine of 30 equals a half. So we can substitute in, so this will become root 3 over 2 cos x plus a half of sine x, and then still equals 2 sine of x. Okay, and then we're going to put the coses on one side and the sines on the other. So this all stays root 3 over 2 cos of x equals, so this is going to be 2 sine of x minus a half sine. So then we're going to simplify that. So it's root 3 over 2 cos x should equal, that's going to become, sorry, this is meant to be a negative, so 2 minus a half is going to be 3 over 2 sine x. So now we can divide both sides by cos x and the root 3 over 2. So basically this is going to be divide both sides by root 3 over 2 cos x. Let's do the same thing to the other side. And you're actually then, because this sine over cos is tan, this is going to mean that we're left with tan of x, remember those cancel, is going to equal, doing some algebra, root 3 over 3. Cool, so now this is a more simplified equation. Now we can use this to find the general solution. And we do this by first finding the reference angle. So your reference angle will then equal the inverse of tan. So your shift tan on your calculator, so tan to the minus 1 of root 3 over 3, which I get to be 30 degrees. So now this is your reference angle, therefore your general solution is x equals your reference angle, so it will be 30 degrees, plus, remember, k 180, because tan repeats every 180 degrees. And remember to include that k is an element of integers. And that's the final answer. Moving on to the next question, 6.2, they've given us a diagram and they've told us that f of x equals cos of the x minus 30, and g of x equals 2 sine x. Some other relevant information about the diagram. And then 6.2.1 is now asking us to write down the coordinates of A. So that's this point over here. And we can see that A is when the graph of f hits the x-axis. So that's the x-intercept. So we know then at this point that y is going to equal 0. So therefore, the f of x is going to be 0 equals, then it's the formula that they've given us, which is cos of x minus 30. And I get that, so from this equation over here, we just substitute in f of x equals 0 because we know that's the x-intercept. So from this we can deduce that we know that cos of 90 is 0. So, but it also is, it's not just a normal cos graph, it's a cos of x minus 30. So what would x need to be for this equation to for this term to equal 90? We know that x needs to be 120. So x is 120 degrees, and you can see that because this cos graph here has been shifted to the right by 30 degrees, because this is about 90, it means it's been shifted by 30. That means it then crosses the x-axis at 120 degrees. So therefore, so for number A, we know that the coordinate A will be 120 and 0. For B, they've now asked us to find the coordinates of C, and this is where the two graphs are equal. So basically then for question B, it's going to be where f of x equals g of x, which just so happens to be the same two equations that we had to solve the general solution for in the previous question. So basically, if we make these equal, we'll see that it's the same general solution that we worked out in the previous. So we know that x equals 30 plus, so therefore, as I said, x equals 30 plus k times 180. And because this is, you can clearly see that this x value needs to be in the negative x plane. So we're going to substitute in -1 for k over here to get what the x value should be at this point. So basically, let k equal -1, and then x will equal 30 minus 1 times 180, which in my calculator I get is minus 150, which makes sense because it's at about minus 150. So we know the x value will be minus 50, and then the y value we can get by subbing into any of the other two values. So if we graph, so if we use this g of x, so we'll know that g of minus 150 will equal 2 times the sine of minus 150. And I'll put this in my calculator and I get -1. So therefore, your coordinate of C is going to be minus 150 and -1. Okay, then moving on, 6.2.2 now asks us to determine the value of x in the interval from -180 to 180 for A, where both graphs are increasing. So we can see that in the F graph, it increases basically from that point over there, and it's going up and up and up and up, and starts decreasing at point D. Same thing goes for the G graph, it starts increasing from about there and it goes past D and starts decreasing there. So basically, from about there until there is where both are increasing. We can see there. So now we have to find out what this coordinate is, what the x value for this coordinate is, and the x coordinate for the D point. So for A, we know that this is the local minimum for the graph of G, and G is just the normal sine graph, G of x. So the local minimum in the negative plane of x will occur at x equals minus 90. So we know that this first point here would be minus 90 degrees. So x needs to be an element of minus 90, and your upper range limit will be this D coordinate, which we know, remember again, is this f of x equals g of x, which we found the general solution again from question 1, which states that x equals 30 when those two are equal. So we can then conclude that this should be at about 30 degrees. So x is an element of 90 to 30 degrees. Cool. Then B is now asking where f of x, well, it's actually f of x plus 10, is greater than g of x plus 10. So if we just ignore the plus 10 for now, where on this graph is f of x greater than g of x? And we can see that it's from point C, because this line of f of x is higher above g of x, from point C all the way up to point D. That's when it crosses over again and f of x becomes lower than g of x. And we know from the previous question that this point C here is at minus 150, and of course point D is at 30. But they're also saying that x plus 10 for each graph. And x plus 10 is the inverse, so it's actually when these two graphs are shifted to the left, so towards the negative side of the x-axis. So therefore the answer is x should be in the range of not a minus 150, but minus 160, because it's been shifted by 10, and then the same, they're not 30, but rather 20 degrees is the upper limit of the range. And that's the answer for B. Okay, and moving on to the next question. Determine the range of y equals 2 to the power of 2 times sine x plus 3. Okay, this is a little bit of a difficult one, but let's just first break it up. So if we first find the range of this term, which is the 2 sine x in the exponent. So first do this, so we know that the range of y equals 2 sine x. So let's just quickly draw this out. So we know that a sine graph looks something like this, and its highest point is at 1 and its lowest point is at minus 1. So that's its range for a normal sine graph. That's just sine of x. But of course it's sine of 2x, so we need to, the amplitude of this graph just gets extended to double basically. So it gets higher, which it peaks at 2 and dips at minus 2. So therefore your range would be y is an element of minus 2 to 2. So using that knowledge, we can then say that the range of y equals 2 sine x plus 3, which is the actual exponent, it's going to be the same range but shifted up by 3. So y is going to be an element of now, so minus 2 plus 3 is 1, and 2 plus 3 is 5. So we've got the range of the exponent. And then we're going to apply the same concept to the final equation, which states that y is 2 to the 2 times sine of x plus 3. And we know that this whole thing's range is over here. So basically we need to find out what the what its lowest y value could be. So 2 at its lowest will be when this entire equation is equal to 1. So we know that y will be 2 because 2 to the power of 1 is 2. And then the upper limit of the range is when that exponent equals 5. So it's when y equals 2 to the power of 5, which of course is 32. So therefore, we can conclude that the range of 2 to the power of 2 sine x plus 3 is y is an element of 1. So this is 2 to the power of 1, which is actually 2. So 2 to 32. And that's your final answer. Concludes question 6. Before I go, I'd just like to give a special thanks to our epic sponsors for making these videos possible. Read all about them in the description below. Be sure to visit our website for more of these tutorials. And if you can't find the answers to the questions you have, send us your questions and we'll respond with a personalized video just for you. And until then, stay epic.